All right, so here's a recap of section 2, 10.2. So in this section we talked about central angles. And remember that central angles, we talked about various types of angles and their relationships within circles. It's important to recognize what a central angle is, where the vertex is on the center point. So that center point of the circle, the vertex is on that center point right here. And then with a central angle, the arc that is inside that angle, whatever the measure of the central angle, that's the measure of the arc. Okay, so the measure of an arc is defined as the measure of the central angle that forms that arc. Make sure that you remember that it has to be a central angle for the measure of the arc and the measure of the angle to be the same thing. We've talked about various types of angles formed by various types of lines and segments that you can have in a circle, but it's only a central angle where the vertex is on that center point, not inside, on the center point. It must be on the center point. And then the measure of the angle and the measure of the arc are the same. So, and then the other things we talked about were major arc, minor arc, and semicircle. Major arcs are the arcs that are bigger than 180. Minor arcs are the arcs that are smaller than 180. And a semicircle is an arc with exactly 180. And so here we looked at some arcs. And so here we're talking about arc RS. And one thing that we discussed in class, and I just want to talk about this a little bit, is that when you're looking at an arc, so in this case arc RS, when it's just using two letters, it's always the shortest distance. So arc RS in this case is 110. So the measure of the angle and the measure of the arc are the same. Now, the next question asked you about arc RTS. So if you want the long way or a major arc, anytime you're naming a major arc, you have to use three letters. Okay, so the first and the last letter are going to be your starting and stopping points, but the middle letter tells you where you're going to go. So this says we're going to go from R to S, but we're going to go through our point T. So that's that one. And we know that a circle has 360 degrees, so if from R to S the short distance is 110, from R to S through point T, the long way around, should be 250. And then if it's RST, again, you'll notice it's the same letters, but this time it's starting at R, ending at T, going through S. So that would be 180. Then looking at whether arcs are congruent, two things have to be true for the arcs to be congruent. First of all, they have to have the same measure, and then second of all, they have to be either arcs in the same circle or congruent circles. So this first pair, it's the same circle, and they're both 80 degrees, so those arcs are congruent. The second one, their measures are both 90 degrees, but one circle is smaller than the other, so those two arcs are not congruent. And then this third example, they're both 95 degrees, so they have the same measure, and they're not part of the same circle, but we do have the radius here and the radius here have the same measure. That's what those tick marks mean. And so the circles are the same size, so those are congruent. All right, the last thing we talked about in this section was arc length, and that's where we just got done talking about the measure of an arc being whatever the measure of the angle is, it's in degrees. now we're looking at the arc length. So if you were to actually take a piece of string and lay it on there and then measure it. So in order to find the arc length, you must know the measure of the arc. So this isn't the same thing as the measure of the arc. This is going to be an actual length, not a degree measure. But you do need to know that degree measure in order to do so, in order to find the arc length. And you take the measure of the arc divided by 360. That's going to tell you what fraction of the circle that arc encompasses. And then you're going to multiply that by 2 times pi times the radius. And if you remember, 2 times pi times the radius is how you find the circumference. So that fraction is going to tell you what fraction of the circle you're actually looking at. And then if you multiply that by the circumference, that'll tell you how much of the circumference that arc is actually including. So here, we're trying to find the measure of this arc, or excuse me, we're trying to find the arc length. We're given the measure of the arc to be 24, and we're given that the radius is 5. So we use that formula, the measure of the arc divided by 360, so 24 divided by 360, and we multiply that by 2 times pi times the radius. And then if you type that into your calculator, you get 2.09 centimeters. All right, so that's all we did. So everything was just extra practice of that. If you want to go back over those problems again for extra practice, go ahead. But I just wanted to do a quick recap of that section.